Welcome back. This is lesson number 3. The topic is still differential calculus. In the previous lesson, there was an activity, and then these were the questions, and these are the answers. Today, the topic is equation of a tangent to a curve. So first of all, you must ask yourself, what is a tangent? So here is the definition. A tangent is a straight line that touches a graph at one point. As you can see, this line is the tangent. Definition. If the function of f is differentiable at c, then the tangent to y equals to f of x at the point P, C and f of c is the line through P with the gradient f prime of c. Does this definition make sense? Okay, don't worry. So here is the explanation. The tangent is a straight line, so its equation can be determined using the formula y minus y1 equals to m into x minus x1, where m equals to f prime of c, and x1 and y1 is the point c and f of c on the curve. Example number 1. Find the equation of the tangent to the curve f of x equals to x cubed minus 4x plus 2 at x equals to 2. Here is the solution. So first of all, we determine the gradient. To determine the gradient, we differentiate the given function or the equation of the curve. Therefore, we are going to have m equals to f prime of x equals to 3x squared minus 4. When we differentiate these two, we are going to get 0. So I didn't write that 0 here. But m equals to f prime of c. But in this situation, our c is 2. Therefore, or it implies m equals to f prime of 2. Therefore, m equals to f prime of 2 equals to 3 into 2 squared minus 4. And the answer is 8. Now determine the value of y1. We use c to obtain f of c. And remember, in this situation, our c is what? It's 2. As you can see, x1 equals to c equals to 2. Then y1 equals to f of c equals to f of 2 equals to 2 cubed minus 4 into 2 plus 2 equals to 2. That's the answer. So it means your y2 equals to 2. Now we have the point x1 and y1, which is 2 and 2. Now we have the value of x and the value of y. So it means we are going to substitute the value of x1, y1 and m into y minus y1 equals to m into x minus x1. Remember, this is the equation of a straight line. You can even use that one of y equals to mx plus c, but you're still going to get the same answer. Therefore, we have y minus 2 equals to 8 into x minus 2. Y equals to 8x minus 16 plus 2. Therefore, y equals to 8x minus 14. This is the equation of the tangent to the curve. Example number 2. The tangent to the curve of g of x equals to 2x cubed plus px squared plus qx minus 7 at the point x equals to 1 has the equation y equals to 5x minus 8. Number A. Show that the point 1 and negative 3 is the point of contact of the tangent to the curve. Number B. Hence or otherwise calculate the values of P and Q. Here we go. Now we have the point. There is the point which is given, which is x equals to 1. Now we take this x equals to 1 and substitute it into the equation of the tangent and solve for y. Therefore, we are going to have y equals to 5 into 1 minus 8, and this is equals to 3. Therefore, the point 1 and negative 3. Number B. Consider the equation of the tangent y equals to 5x minus 8. The gradient m equals to 5 equals to g prime of x, because to determine the gradient we differentiate the equation of the curve. Therefore, we are going to have 5, which is the gradient, equals to 6x squared plus 2px plus q. Therefore m equals to g prime of 1 equals to 5. It implies 5 equals to 6 into 1 squared plus 2p into 1 plus q. And then we remove the brackets, we're going to get this, and then therefore we'll have q equals to negative 1 minus 2p, and then this is equation 1. We have just proved that the point 1 and negative 3 is the point of contact to the curve. Then we have y equals to g of x. Don't be surprised to see this y. We are given g of x, but g of x is the same as y. Therefore, we have y equals to g of x equals to 2x cubed plus px squared plus qx minus 7. Now you substitute the value of x and y, which is x equals to 1 and y equals to negative 3, into this equation, and this y is equals to negative 3. Where there is x, we are going to put 1. Therefore we have negative 3 equals to 2 into 1 cubed plus p into 1 squared plus q into 1 minus 7, and then we remove the brackets. Therefore we are going to have q equals to 2 minus p, and then this is equation 2. Now we have two equations, equation 1 and equation 2, and they are all equal to q. So it means we are going to equate these two equations. Then we are going to have this, and then when we simplify everything, we are going to get p equals to negative 3 because this is our variable. And then substituting back the value of q into maybe equation 1 or equation 2, it's up to you. You are going to get your q equals to 5. Lastly, here comes your activity, which is activity 3. And please make sure you do this activity, because in the next lesson I'm going to provide you with the answers. And please don't forget to subscribe. To subscribe here doesn't mean paying. It means to apply to take part in the activity. Thank you.